Self-practice 5.5, questions number 1. Determine whether the following sequence is a geometric progression. Justify your answer. Geometric progression is a sequence of numbers where each term is obtained by multiplying the previous term with a constant value, which is known as the common ratio. So to determine whether the sequence is a geometric progression, so we're going to find the ratio between any two consecutive terms. If it is a constant value, then it will be a geometric progression. So for questions A, first we're going to find the common ratios. So the first two terms I'm going to use is 40 and 120. So I'm going to divide 40 with the previous term, which is the 120. So this will give you the answer of 1 over 3. Then I will continue to find the common ratio between the terms 40 over 3 and the previous term, which is 40. So this is the same as 40 over 3 multiplied by 1 over 40. So this 40 here will be cancelled, therefore the answer will be 1 over 3. So as these two common ratio that we find, they are a constant value, which is 1 over 3. Therefore, this sequence is a geometric progression. Questions B. So first we're going to find the ratio between 0.003 with the previous term, which is 0.03. So the ratio will be 0.1. And if we use the ratio of 0.0003 over the previous terms, which is 0.003, the answer will be 0.1 as well. So for this sequence of number, they are having the same ratio. As this sequence are having the same ratio, which is 0.1, therefore, this sequence of numbers is a geometric progression. Question C. Even though the sequence given here is in the form of algebra, but to determine whether it's a geometric progression or not, we still need to find the ratio between any two consecutive terms. So first, I'm going to find the ratio using the terms 2x and the previous term, which is the x plus 1. So as we cannot continue from here, so this will be the first ratio that we find. So if we continue, I'm going to use the terms 5x plus 12, and I'm going to divide it with the previous term, which is the 2x. So if we simplify this, this is actually the same as 5x over 2x plus 12 over 2x. So if we simplify this, it will be 5 over 2 plus 6 over x. So as these two ratios, they are not the same. Therefore, this sequence is not a geometric progression. Questions number 2. Complete the network diagram below. Given that the relationship of each of the following network is a consecutive terms in a geometric progression. In a geometric progression, we know that the ratios between any two consecutive terms is a constant. So to find the missing terms, for example, of these geometric progressions, when we look at in these directions, let's say these missing terms here, we label it as x. So to find the common ratios for this geometric progression that I highlight here, I can use the x, divide it with the previous term to find the common ratio. The common ratio that we find here will be the same as if you use number 8 divide by 8, which is the two consecutive terms. Now to solve this, we're going to do the cross multiplications. So here x times x, I will get x squared. 1 over 2 times 8 will equal to 4. Now move this square to the right hand side, you will have square root. And remember that for square root, you're going to have to answer plus and a minus. Therefore, the x can be a plus or a minus 2. Now for this geometric progression, I'm going to choose the positive 2. as it will give me the correct answer as well. So for this, I'm going to choose 2 for the x. Now, if I choose 2 for my x, then if you use the consecutive term add and 2, add divided by 2, you'll find that these geometric progressions, you are multiplying the previous term with number 4. So the next one here, add times 4, you'll find that these missing terms here will equal to 32. Next, I'm going to solve for these geometric progressions, and I'm going to look at this geometric progression in these directions. So you can use the same concept here. Let's say for these missing terms here, I use the letter y to represent it. So here, the common ratio will be y divided by the previous term, which is the number 2. This ratio will be the same as you're using add divided by the y. Again, do the cross multiplications, you'll find that y squared equal to 16. So move the square to the right hand side, it will be plus minus square root 16. So the answer will be plus minus 4. So in this case, I'm going to choose just the positive 4 for this y. So if I put a positive 4 here, 4 divided by 2, these geometric progressions, you are multiplying 2 to the previous terms. And for the last one here, for these geometric progressions, if I look at it from these directions, you can use the same method here if you can find the common ratio straight away. So here z divided by previous term, which is the 1, will equal to the ratio if you're using 4 divided by the previous term, which is the z. Again, cross multiply this, z squared will equal to 4. Therefore, z is equal to plus minus square root of 4, which is equal to plus or minus 2. So in this case, I will just choose the positive 2 here. So if I put number 2 here, I will find that 2 divided by 1, this geometric progression is you are used multiplying 2 to the previous terms. Questions B. So first, I'm going to find the missing terms in these geometric progressions in these directions. So I have 2 terms that I know here, the consecutive terms. So I can find the common ratio using 1 over 24 divided by 1 over 12. So the answer will be 1 over 2. Therefore, these geometric progressions, you are multiplying 1 over 2 to the previous terms. So to find the missing one here, I'm going to multiply 1 over 3 with the common ratio 1 over 2. So the answer will be 1 over 6. Next, I'm going to find the missing terms for these geometric progressions. And I'm going to look at it in these directions. So again, I have 2 consecutive terms that I know. So I can find the common ratio 1 over 12 divided by 1 over 3. So the answer will be 1 over 4. So these geometric progressions, you are multiplying 1 over 4 to the previous terms. So to find the missing one here, we just need to multiply the 1 over 12 with 1 over 4. So the answer will be 1 over 48. Next, I'm going to find the missing terms for these geometric progressions in these directions. So here we have already know 2 consecutive terms, so I can find the common ratio straight away. 1 over 12 divided by 1 over 6, the answer is 1 over 2. So you are multiplying 1 over 2 to the previous terms. To find the missing one here, we're going to multiply 1 over 12 with 1 over 2. So the answer will be 1 over 24. Next, I'm going to find the missing terms for these arithmetic progressions, and I'm going to look at it in these directions. So here we know 2 consecutive terms. To find the common ratio, we're going to use 1 over 24 divided by 1 over 48. The answer will be 2. So these geometric progressions, you are multiplying 2 to the previous term. To find the missing one here, I just need to multiply the 1 over 24 with number 2. Therefore, the answer will be 1 over 12. For these geometric progressions, I'm going to look at it in these directions. So we cannot find the common ratio straight away from this geometric progression as we didn't know the two consecutive terms. So we're going to use the method that we use to solve for the questions A. So let's say the missing terms here, we're going to label it as P. So the common ratio for this geometric progression, we can find it by using what P divided by the previous term, which is the 1 over 3. This ratio that we find will equal to, if we use the other consecutive term, which is the 1 over 12, divided by the previous term, which is the P. So here we're going to do the cross multiplications. So P times P, you get P squared equal to 1 over 3 times 1 over 12. The answer will be 1 over 36. So P will equal to plus minus square root 1 over 36. So the answer will be plus minus 1 over 6. So the answer can be a positive 1 over 6 or a negative 1 over 6. So in this case, I'm just going to choose the positive one. So I'm going to put 1 over 6 in these missing terms here. Questions number 3. Given that x minus 2, x plus 1 for x plus 4 are 3 consecutive terms in a geometric progression, state the positive value of x. Hence, list the first 3 terms and state the common ratios. To find for the value of x, we're going to use the common ratio. As you are dividing 2 consecutive terms, you're going to get a constant value. So first, we're going to use these 2 consecutive terms. So if I use 4x plus 4 and divide it with the previous terms, x plus 1, I will get a constant value. This constant value will be the same as you are using these 2 consecutive terms. So x plus 1 divided by the previous one, x minus 2 will give you the same constant value. Now to find for the x, here we're going to do the cross multiplications. So here we're going to get bracket 4x plus 4 times x minus 2 equal to x plus 1 times x plus 1. So here we are going to expand this. So the first one here we're going to get 4x squared minus 8x plus 4x minus 8 equal to x squared plus 2x plus 1. Then what you're going to have here is a quadratic equations. And to solve for the quadratic equations, first we're going to write this in general forms. So I'm going to move everything to the left hand side. So here I'm going to get 4x squared minus x squared as I move the x squared to the left hand side. This part here, negative 8x plus 4x will equal to negative 4x. And move this positive 2x to the left hand side, minus 2x. Minus 8, and this 1 move to the left hand side will be minus 1 equal to 0. So here we're going to get 3x squared minus 6x minus 9 equal to 0. We can simplify this equation further by dividing every terms with number 3. Therefore, you're going to get x squared minus 2x minus 3 equal to 0. And we can factorize for these quadratic equations. So factorize this, we'll get bracket x minus 3. Another one will be x plus 1 equal to 0. So the answer for the x will be x equal to 3 or x equal to negative 1. So this question has stated state the positive value of x. Therefore, x equal to negative 1. For this answer, we're going to reject it. And we're going to accept the answer x is equal to 3. So now we already know the value of x. So now we're going to list the first 3 terms. So the terms number 1 here is the x minus 2. So as we know, the x is equal to 3, so just substitute here. So 3 minus 2, so the first term will equal to 1. The second term is the x plus 1. So this will be 3 plus 1, which is equal to 4. The third term is the 4x plus 4. So when 4 times 3 plus 4, this will equal to 16. And the question also asks you to state the common ratio, which is the R. So we can find the common ratio by dividing two consecutive terms. So 4 divided by the previous one, which is 1. So the common ratio will equal to 4. Self-practice 5.6, questions number 1. Find a way to finish box by choosing the correct answer. So as this exercise is about the number of terms in the geometric progressions, therefore we can always refer to this formula, Tn equal to ARn minus 1, to solve for the questions that we have here. So first we're going to start from this start box here. So we're going to label this as the A. So the first information will be the first term is equal to 12. So the first terms will also equal to the A in the geometric progressions. And the third terms is equal to 27. So we want to find the fifth term. So first, we're going to find the common ratio first. So this 3, I can substitute it with the ARn minus 1. So here the A will be the 12. So Rn minus 1 will equal to 3 minus 1 equal to 2. This is equal to 27. So R squared equal to 27 divided by 12. So 27 over 12, we can simplify this by dividing it with number 3. Therefore, R squared is equal to 9 over 4. So R is equal to the square root of 9 over 4. Solve this, you will get the common ratio is equal to 3 over 2. Here I'm going to take the positive value of this square root for the common ratio, as if you look at the possible answer that I have for the fifth terms in the questions A, all of them are in a positive number. So now I know the R. To find the T5, the fifth terms here, so we're just going to use the formula ARn minus 1. The A, which is the first term, is equal to 12. The R is 3 over 2. So n minus 1 here will be 5 minus 1, which is equal to 4. Solve this, you'll find that the answer is equal to 243 over 4. So the answer for this questions A will be this one. We are going to label the next box here with B. So if T1 equal to 4 and T3 plus equal to T2 plus 24, find the positive value of R. So here we want to find the common ratio. So for this questions B, the first term, which is equal to 4, so this is equal to the A, the first terms. And the equations given here is T3 equal to T2 plus 24. So we're going to use this equation to help us to solve for the R. So next we're going to replace this T3 using the formula ARn minus 1. So here the A will be 4. R, so n minus 1 is 3 minus 1, which is equal to 2. And for this T2, we're going to replace it with the ARn minus 1 as well. So here will be the A is 4, R, n minus 1 is 2 minus 1, so the answer is 1. Now, when we look at this, we have the highest power of R here equal to 2, which indicate this is a quadratic equations. Now, to solve for the R here, we're going to write this in general form. So I'm going to move everything to the left-hand side. So 4R squared minus 4R minus 24, this is equal to 0. Next, I can simplify each terms here by dividing each term with number 4. Therefore, I'm going to have R squared minus R minus 6 equal to 0. So here we can factorize for these quadratic equations. So we're going to have R minus 3 The other one will be r plus 2 equal to 0. Therefore, the r is equal to 3 or r is equal to negative 2. Now, if you look at the questions B here, find the positive value of r. Therefore, the answer for B will be r equal to 3. So the next questions here, we're going to label this as C. Given that negative 3, 6, negative 12, and so on until negative 192, find the number of terms. So for these geometric progressions, the first term, which is the A, is equal to negative 3. And for the common ratio, we're going to use the second terms, which is the 6 divided by the first term, which is the negative 3. So the answer for the common ratio R is equal to negative 2. So we want to find until negative 192, there are how many terms? So the last one here, we're going to label this as the nth term. Therefore, Tn is equal to the negative 192. So the Tn here, we're going to replace it with the formula AR n minus 1. So we know that the A is negative 3, the R is negative 2, and n minus 1. So this one is equal to negative 192. So first, move the negative 3 to the right hand side. So it will be negative 192 divided by negative 3. So the answer is 64. So next, by refer to the law of indices. A to the power of m divided by a to the power of n. This one is equal to am minus n. Therefore, I can write the negative 2 to the power of n minus 1 as bracket negative 2 to the power of n divided by negative 2 to the power of 1. So this one is equal to 64. Next, I'm going to move this negative 2 to the right hand side. Therefore, I'm going to get negative 2 to the power of n equal to negative 2 times 64, which is equal to negative 128. Now, to solve for the n's, for the right hand side, this negative 128, we are able to write it in the number in base 2. So negative 128 is the base negative 2 to the power of 7. So when the left hand side and right hand side, we are able to write it in the same base. Therefore, to find the n, we just need to compare the power. Therefore, the n is equal to 7. I'm going to label the next questions here as D. So given that A, which is the first term, equal to 50, and the fifth terms, the T5 is equal to 20 and 12 over 25. This T5, we can replace it using the formula AR n minus 1. So the A will be 50, R, n minus 1 here will be 4. Next, I'm going to move this 50 to the right hand side. That is going to be 20 and 12 over 25 divided by 50. Solve this using your calculator and you'll find that the answer is 256 over 625. The easiest way to solve this is using your calculator. Move the power of 4 to the right hand side. Then R will be the fourth root of 256 over 625. So the answer is 4 over 5. Or from this part here, we can change this 256 and 625 into a number with a power of 4. Now, 256 is equal to 4 to the power of 4, and 625 is 5 to the power of 4. Next, I can write this as 4 over 5 to the power of 4. So on the left hand side and right hand side, we have the same power. So in order them to be equal to each other, therefore I can just compare the number. So R is equal to 4 over 5. So I'm going to label the next questions here as E. So given that R, the common ratio, is equal to 1 over 2, and the third term, T3, is equal to 1 over 6. So find the T10. To find the T10, we need the informations of A and R. So we already have the informations of R. So here we're going to find the missing information, which is the A. To solve for the questions E, we're going to find the A using the informations. The third term is equal to 1 over 6. So the T3, we can replace it with the AR 3 minus 1. So A, we know that the R is equal to 1 over 2. So 3 minus 1 is equal to 2. So 1 over 2 to the power of 2 is equal to 1 over 4. So here to find the A, you can move this 1 over 4 to the right hand side and solve this using your calculator, which will be 1 over 6 divided by 1 over 4. Or I can just multiply 4 on both sides in order for me to cancel the 1 over 4 on the left hand side. By doing this, you'll find that the A is equal to 4 over 6. Simplify this. The A is equal to 2 over 3. Now to find the T10, the A is 2 over 3, the R is 1 over 2, and minus 1 will be 10 minus 1, which is equal to 9. Solve this using your calculator, then the answer will be 1 over 768. The next questions, we're going to label it as the questions F. So find the fifth terms for the sequence x plus 1, x plus 3, x plus 8, and so on. So here first we need to find what is the value of x. So to find the value of x, we're going to use the ratios, because the ratio of any two consecutive terms will equal to each other. So if we take x plus 3 over the previous terms, x plus 1, the value that we have here will equal to, if you use the x plus 8 over the previous term, which is the x plus 3. To solve this, we are going to do the cross multiplications here. So it will be x plus 3 times x plus 3 equal to x plus 1 times the x plus the 8. So here we just need to do the expansions. So on the left hand side, you're going to get x squared plus 6x plus 9. Whereas on the right hand side, after the expansion, you're going to get x squared plus 9x plus 8. So the x squared on both sides, they will be cancelled as you move the x squared. Let's say you move the right hand side, the x squared, to the left hand side, it will be x squared minus x squared. So the x squared here, both of them will be cancelled. So next, to solve for this one, we are going to move the x on one side. So 6x minus 9x equal to 8 minus 9. So negative 3x equal to negative 1. Therefore, the x is equal to negative 1 divided by negative 3, which is positive 1 over 3. So now we know that the value of x is 1 over 3. Therefore, the first term, which is the A, which is the x plus 1, will be 1 over 3 plus 1. So this will be equal to 4 over 3. And the second terms, the T2, is equal to the x plus 3. So when 1 over 3 plus 3, the answer will equal to 10 over 3. So now when we know the T1 and T2, now we can find the common ratios. So the common ratio, we are going to divide the value of T2, 10 over 3 over 4 over 3. So here you can solve this using your calculator, and if you do it manually, then it will be 10 over 3 times 3 over 4. So simplify this, you'll find that the R is equal to 5 over 2. So now we already have the informations of A and R. Now we can find for the fifth terms, which is the T5. So T5 equal to, using the formula, the A is 4 over 3, the R is 5 over 2. So n minus 1, 5 minus 1 is equal to 4. So solve this using your calculator and you find that the answer is 625 over 12. So the next questions, we are going to label it as the questions G. So given that 0.12, 0.0012 and 0.000012 finds R. So to find the common ratio R, we're going to divide the two consecutive terms. So we're going to take 0.0012 here and divide it with the previous term, which is 0.12. So of this, you're going to find that R is equal to 0.01. Therefore, we already finished the box. Questions number 2. The diagram on the right shows a ball bouncing on the floor. The maximum height of the bounce of the ball is 3 meters and the height of each bounce is 95% of the previous bounce. From which bounce onward would height be less than 1 meter? So from the information given, the maximum height of the bounce will be 3 meters. So this 3 meters will be the first bounce. As we continue, the height will be 5% less compared to the previous one. Now to find the next height of the bouncing ball, we are going to multiply the previous one, which is the 3 meters, with 95 over 100. Solve this, you'll find that it will be 2.85 meters. This will be for the second bounce. So as we continue, the third bounce, the height will be the previous height, 2.85. You multiply it with 95 over 100. So it will be 2.71 meter. So if you look at the pattern here, you are multiplying a constant, which is 95 over 100 or 0.95 to the previous terms. Therefore, the height of the bouncing ball here will create a geometric progression. So it will start from 3, followed by 2.85, followed by 2.71, and so on. So here the A, which is the first term, will be the 3. And the R will be the constants that you multiply to the previous term, which is the 95 over 100. Or we can also write this as 0.95. Here we want to find which bounce onward will the height be less than 1 meter. Here we want to find the number of terms which is less than 1. So here I can write this as Tn less than 1. We're going to find the n, which is the number of bounce. So Tn, the formula is Arn minus 1. So here we know that the A is 3. So the R, I'm just going to use the 0.95 here. So it will be n minus 1 less than 1. So solve this, we're going to find the n, which is the number of bounce. So first I'm going to move the 3 to the right hand side. Therefore, 0.95 n minus 1 will be less than 1 over 3. So next, for this 0.95 to the power of n minus 1, using the law of indices, I can write this as 0.95 n over 0.95. Next, I'm going to move this 0.95 to the right hand side. Therefore, 0.95 n less than 1 over 3 times 0.95. Solve this using your calculator. The answer will be 19 over 60. To solve for the n's, as on the right hand side, the 19 over 60, we are not able to change it to the number in the base of 0.95 to compare for the n's. So here we're going to solve this using the logarithms. So first, on both sides, I'm going to log it with log base 10. So on the left hand side, using the power law, I can move the n's to the front. Therefore, n times log base 10 0.95 will less than the log base 10 of 19 over 60. So next, I'm going to move this log base 10 of 0.95 to the left hand side. Now remember, the value of log base 10 to a decimal will give you a negative answer. Therefore, when you move the log base 10 0.95 to the right hand side to find for the end, the signs of the inequality signs will be reversed as you are dividing it with a negative number. Solve this, you will find that the n is greater than 22.41. So n is representing the number of bounds, so it has to be an integer. Therefore, the nearest one will be 23. Therefore, the n will equal to 23. So from 23 bounds onwards, the height of the bounds will be less than 1 meter.